So I know I have a lot more newer viewers here, and I'll go over a few papers here that I printed out, very quick, simple principles and my stance on black holes and why um, the establishment is just, they lost it. They went off the deep end back in the 60s and they haven't come back. Black holes don't exist. They're fictional. And let's go ahead and start off with that. Um, People new to this theory, young stars evolve. They're born really small, they expand greatly, and then they start cooling, shrinking, and dying, and differentiating their interiors, becoming what are called planets. So planets and stars are the same things. I know, shocking to those who are new to that. I mean, it's going to be pretty strange to look at the stars differently now because of it. Those little dots in the sky aren't, LEDs. They're not holes in the ceiling. They're young Earths, all of them. So get a pair of binoculars, and if it's clear, dark night away from the city and light pollution, go ahead and look it up at those, and that's how many young Earths. You're looking directly at young Earths, visibly, directly seeing young Earths very, very, very early in their evolution. Black holes don't exist because the theory that tries to explain why they exist is just total nonsense. There's no room for a black hole to exist. A big, massive star loses its mass, cools, evolves, and differentiates its interior, forming a planet. A planet, which is, the planet is the ancient star. I already said that. So there's no room for a black hole to even be on here. No room at all. This represents outer space right here. And this is dust and gas, and these are the small bits and chunks of leftover stars that have been impacting with each other. The black hole theory, I don't even know why it exists, to be honest. I don't know why they invented that idea. And Stellar Mass Black Hole, I'll link this paper to the bottom. Of course, I haven't even touched it. It's written June 24th, 2015. Over 4 years ago. It's been around for a while. The phase transition principle. This is very important, very simple. I wrote this January 12th, 2016. According to stellar metamorphosis, stars cool and die to become rocky, differentiated worlds many billions of years into their evolution, and they are called planets and exoplanets. As they evolve, they are comprised of the four classical phases of matter: solids, liquids, gases, and plasmas. And the principle as follows. It's a very short paper, very simple paper, very to the point paper. As stars cool and die, the matter they are comprised of will phase transition from plasma to gas to liquid and solid material. Young stars are composed of plasma. Middle-aged stars are gas giants. They're gaseous and have supercritical material in the centers, and they're forming the solid rocky ball in their centers. Eventually that thick atmosphere dissipates and leaving the solid rocky ball in the center. It still has things like lava, mountains of fire. It's a very old star, but a lot of Earths that we're going to find out there, when our technology gets advanced enough, we're going to find the other Earths have life like us, and volcanoes and fish and trees. And it's going to be very similar, although the gravity is going to be different on some of these worlds. So it should be pretty interesting in the future. Like, it's 2019 now. Can't imagine what life is going to be like in the year 4000. I'm pretty sure we're going to be out and about exploring the galaxy. We're a little bit too, we live in a strange time where we're too late to be the ones to first explore the Earth, and we're too early to be the ones to explore the galaxy. So we're in this gray area that kind of stinks a little bit, but we can use our imaginations. Anyways, I'll link this phase transition principle paper to the bottom. This one's pretty interesting. Defining atmospheric depth in stellar metamorphosis. When we think of the atmosphere, we think, well, yeah, it's what you're breathing, right? But when you think of the phase transition principle, you kind of look at the stars as being much more energetic in their past. The Earth was vastly more energetic. So how deep was the atmosphere of the Earth when it was a young, hot star? The atmosphere, I guess, went straight through the center of it because it was totally plasma. So it was all atmosphere. So the atmospheric depth, I think. Oh, okay. I'll just read this paper out too. The depth of the star's atmosphere is defined in stellar metamorphosis. So the thickness of a star's atmosphere is defined as depth of direct convection of liquid and or gaseous and or plasmatic material that is gravitationally held to the star all the way to the boundary of outer space. So essentially, the atmosphere is material that moves. If it's solid material and doesn't move, the atmosphere is the material that you're navigating. So in this theory, the oceans are the atmosphere, even though from a geological standpoint, geologists don't look at the ocean as being atmospheric material. But I think it's more appropriate to look at it like that. And I'll go ahead and continue reading this. This means that the convection of the material of a star has to reach directly to outer space from any given point in the interior of the star. For instance, Earth has convection in its interior in the form of magma, but has a solid crust which separates a large portion of magma from the convective gaseous matter on the surface. The magma convection is blocked by the non-convective crust, the solid material, the rocks, is therefore not the atmosphere. If the magma reached directly to outer space via convective transfer to the gaseous atmosphere, if the magma reached directly to outer space via convective transfer to the gaseous atmosphere, it can be considered the star's atmosphere. I made a typo there. This means that the atmosphere is therefore defined in terms of thermodynamic processes, and is not human-centered as it currently is defined by the establishment dogma on Earth. As well, it means since the majority of less evolved stars do not yet possess solid surfaces, their interiors are probably mostly convective, meaning their interior depths can be considered atmospheres, regardless of the pressures defined on our world as being atmospheric pressure. What this does is remove the human-centered definitions, as stars as they evolve do not have humans for the majority of their early evolution, or life in general. So they should not have their physicality defined in terms of human experience. This plays an additional supportive role in defining weather as well, as weather on less evolved stars is much more violent than anything found on Earth. Viewing lava as a meteorological phenomenon will be required to understand stars in their true form as they evolve. So what this paper does is reintroduce a concept that is seemingly familiar. And the seemingly familiar concept was rooted in our sort of self-centered, human-centered viewpoint. And it's really important to look at this type of viewpoint and kind of remove our centered worldview that's centered on our experience, because the universe isn't centered on us. And that's a big problem I see with astronomy. A lot of the astronomers, they sort of just, they look at themselves and then they project themselves onto the stars and project their own beliefs onto the stars. But really, the stars are independent of us. I mean, of course, they create life, but if humanity were to vanish, the stars are going to be still doing their own thing, right? And that's how we should kind of look at it. We shouldn't look at it as, oh, well, we're the number one. Oh, we're the only ones that matter. Everything should be centered on our own personal experience. And you have to sort of like look at it and be like, well, wait a second. The type of physical processes that mostly occur in the galaxy are far beyond our own individual experiences, far beyond our own ability to manage heat and temperature with our own, metabolism and our own, homeostasis with the environment that we're in now. The majority of the worlds that we're going to be finding are far beyond our capacity to survive on, like gas giants. We can't live inside those atmospheres. A lot of them are too toxic, but and the pressures are too high, and a lot of them are too hot, and some of them too cold, and it's various stuff like that. So I think it's best to try to remove our worldview as being centered on us and take the worldview and bring it to another level. A worldview that's centered on a more holistic view of what's happening in the galaxy. And I think that's just another step to take that's sort of removes our ego as well, because a lot of astronomers and geologists, they're very egocentric. They view themselves as being number one, and the world around them is number two, and that's not true at all. Nature is number one, and we're at the will of Mother Nature. I'm pretty sure about that. So, anyways, the next one is the stellar foundation structure principle. As stars evolve into stable rocky life-hosting structures, it is required to define the process of foundation structure formation with a simple principle. Okay, here we go. As stars cool and die, their cores form first, and then layer heavy material on these cores as the thick atmosphere begins dissipating and evaporating. This means the core accretion happens in the interior of the star alongside differentiation itself. The principle is stated as follows. Accretion of a stellar core happens simultaneously as the differentiation process itself. This means as planets are formed inside of stars, the accretion of the material is not separate from the differentiation process. It means as well that inhomogeneous accretion is the rule of thumb, as the iron-nickel core forms first in the interior of the star. The iron-nickel core is a foundational structure to start off the longest process of stellar evolution, when the star becomes the life-hosting world through all stages of plasmatic and gaseous structure, finally to rocky, stable, life-hosting structure. Any theory that violates this principle is invalid and inaccurate, such as the iron catastrophe, the core accretion model of planet formation, and the nebular hypothesis. None of those theories actually explain what happens to stars as they evolve. None of them can explain why all the exoplanets are different. None of those ideas can explain why the objects in our solar system are like a fruit salad. They're all very, very different. And unless you start to look at them as being independent objects, the polymetamorphic idea where it's many different forms and stages of metamorphosis that these stars are undergoing. They're not all from the same gas cloud, like the establishment says. They're not all formed from the same material as the sun. We've already falsified that with the Genesis mission when it found the DH ratios were different from the sun and the earth. And it's like these people, the astronomers, they sort of live in denial day after day after day. And to really break free of that, you have to remove your mind from the old ideas. The nebular hypothesis, which is over 200 years old. The iron catastrophe, which was it's a catastrophic, hypothesis to begin with. That's the idea that all the iron just sunk into the center of the earth after the earth formed. What moved all the rocks out of the way so the iron could sink to begin with? It doesn't make any sense. So not only did they have the iron sinking in the center, all the stuff that was in the way had to have come outwards too. It's what? It doesn't make any sense. If you're going to form an iron core, you have to start with that first, when the object is very gaseous, very large, and very hot. And then the iron collects in the center as a vapor, and a superheated vapor, which condenses and crystallizes, and it forms outwards. I have that in one of the videos, one of the graphics videos Baz made. It overviews that process, but that's the stellar foundation structure principle. But basically, what we have here is a different worldview. I wanted to talk about these specific papers in specific, not the black hole one, but the other principal papers, is because they only had between 25 and 32 views on VIXRA. I think maybe 5 or 6 more views per paper would be pretty cool. I just recently counted up all the views on the VIXRA papers, and it's over 52,500 views. So shout out to Phil Gibbs for allowing something like that to exist and defending it against a lot of the nasty, negative dogmatists that just want to ridicule you and put you down and tell you, you're uneducated and you're a fool. And, they won't allow for outsiders to publish in their esteemed journals. And the fact that VIXRA exists is it's just fantastic. Really crazy or unique ideas can be heard without having to go through some process where some faceless person can just shoot you down and throw your paper in the trash like they do a lot of the times. And it serves as a reminder that ideas, they don't just exist in academics, okay? Ideas, great ideas exist all over the population on earth. There are people out there that have great ideas that, need a way to get those ideas out, to share them, and to put a timestamp on them to say, hey, listen, I did think about this. This is an idea that is very important, something that is really special and that needs to be developed. And just because you're not in academics or you're not a part of some university system doesn't mean that those ideas are all trash. It just means that that's just how life works sometimes. Sometimes people like myself who aren't even involved in the university system and the hierarchy in there can have really freaking good ideas, and we need a way to share those ideas. And Philip Gibbs realized that. Thanks a lot, man. If you're ever watching these videos, I really appreciate it. But anyways, I think I made this video long enough. I'll link all these papers to the bottom. Later, y'all.